Let's talk about generic classes and inheritance. So let's say we're building an e-commerce application. So here we can have objects like products, categories, shopping carts, and so on. So let's start by defining an interface called product. And here we add two properties, name of type string and price of type number. Now, let's say we need a mechanism for storing these objects. So I'm going to define a class called store. Now, we want to be able to store different kinds of objects, products, orders, shopping carts, and so on. So here we need to add a generic type parameter and make this class generic. Now, in this class, we can have methods like add, remove, and so on. But first, we need an array for storing these objects. So let's add a property called objects of type T array. Okay. Now, here we have a compilation error because we haven't initialized this property. But in this case, I don't want to create a constructor because it doesn't really make sense to create a new instance of this class and give it an empty array. This is just unnecessary. It's better to give this responsibility to this class itself. So I'm going to initialize this directly right here. Good. Now, let's add a new method like add, which takes an object of type T and returns void. Now, in this method, we say this.object.push object. Okay. Now, in our current implementation, we can access the object's property from the outside, but we shouldn't be able to because we can accidentally wipe out this array. So we can create a store object, new store of product, and then we can accidentally set this.objects to an empty array. Okay. So we need to make this private so it's only accessible within the store class. So let's make this private and rename it to underline objects. Good. Now we cannot do something crazy like this. Okay. So we have a generic class. Now let's see how we can extend this class. I'm going to take you through 3 different scenarios. First, we're going to create a new class called compressible store. So in this store, whatever we add ends up getting compressed. So here we're going to extend the store class, which is generic. But look, we have a compilation error saying cannot find name T. So the compiler doesn't know what T represents here. So if we try to create a new instance of this class, new compressible store, look, currently we don't have a chance to pass a generic type argument like product. So what we need to do here is to add a generic type parameter here as well. Now the compiler knows that whatever we pass for T, like here, is going to be used as the argument for this generic class. Okay. Now in this class, let's add a simple method like compress. Okay. So now we have a compressible store. And in this store, we have 2 methods, add, that takes a product object, and compress, that we implemented in this new class. So in this scenario, we are passing on the generic type parameter. Okay. So the generic type parameter that we have in the base class is also going to be used in the child class. Okay. Now let's look at another scenario. So let's define another class called searchable store of type T that extends store of type T. Now in this class, we want to implement a method for finding objects. So we add find that takes a name parameter of type string and returns T or undefined in case we cannot find the given object. Now, here we type return this.object, but this property is not available because we made it private. So earlier I told you that private members are not inherited in child classes. So to fix this problem, we need to go on the top and make this property protected. Now, back over here, we can access this.underline objects. Now here we call the find method. Now the find method needs a predicate, which is an arrow function that takes an object and returns a Boolean value. So we can take an object and then say object.name should equal to the name argument that we receive in this method. Now here we have a compilation error saying property name does not exist on type T. So the compiler doesn't know that this type T has a property by this name. Now here we can solve this problem by applying a constraint. So over here, we can say t extends an object with this shape, name string. So now we can use this generic class for finding any kind of object that has a name property. It doesn't have to be product. It could be anything. As long as we have a name property in that object, we can use this class to store that object and find it. Okay? So in the second scenario, we are restricting the generic type parameter. Now the last scenario. Let's say there are certain operations that can only be performed on products. So here we define a new class called product store that extends store of product. So in this scenario, we don't have a generic type parameter here because we're dealing with a very specific store. I don't want this to be generic. And for this reason, I've fixed or terminated the generic type parameter. So in this scenario, we are fixing or terminating the generic type parameter. Now, in this class, we can add a method like filter by category. So this operation is very specific to products. We don't want to use that in a user store or in a shopping cart store, right? So here we add a parameter called category of type string and return a product array. Then for simplicity, I'm just going to return an empty array. So here's what you need to take away. When extending a generic class, we have three options. We can fix the generic type parameter. We can restrict it, like in this case. We can apply a constraint, or we can simply pass it on to the child class.